Section number 53 is entitled Dividing Square Roots. Now, we've already spoken about how to divide square roots, but let's devote a whole section to it. This is one of the bigger rules that we will use. The other rule is do the division first. If you have the square root of 25 over 4, you should ask yourself, what's the square root of 25 and what's the square root of 4? And in this case, you know both of those answers. Now, if you had 200 over 2, the square root of 200 over 2, you should ask yourself, do you know the square root of 200? Do you know the square root of 2? The answer is no. Then you might consider doing the division. 200 divided by 2 is simply 100. And you know the square root of 100 is the number 10. If you were asked to do or compute the square root of 200 over 5, well, you don't know the square root of 200, you don't know the square root of 5. So you probably should do the division, and you'll get 40, a smaller number than 200. But you don't know the square root of 40. But I'd rather break down the square root of 40 than the square root of 200. The largest number on our list that goes into 40 evenly is 4. And it goes in 10 times. So the square root of 4 times the square root of 10. The square root of 4 is 2. And the square root of 10, I don't know. Remember, here is our list. 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, 7 squared, 8 squared, 9 squared, 10 squared, 11 squared, 12 squared, 13 squared, 14 squared, 15 squared. I may be able to say those 14 numbers real quickly, but trust me, I don't know that list. I'm very quickly asking myself, what's 2 squared and 3 squared and 4 squared and 5 squared, etc. Okay, that you have to know. Now, the largest number on that list that goes into 40 is 4. Nothing else. It won't be anything above 40, like 49 or 64. Now, what if you're given, let's do another problem. What if you're given the square root of 30 divided by the square root of 50? Well, you don't know the square root of 30, you don't know the square root of 50. So what you can do is say, well, this is the square root of 30 over 50. And at least I can reduce it. That is, I get the square root of 3 over the square root of 5. At some point you'll realize you could have done that at the beginning, as long as they're both under square root signs. And if they had numbers here, they'd have to be the same number. My numbers are understood to be 2. It's understood to be 2 here and here. Okay, so now you say, well, I reduced it as much as I can, but I have a radical in the bottom. That means I want to change the way it looks. I multiply top and bottom by square root of 5 for one reason. The square root of 5 times the square root of 5 doesn't have a radical. And 3 times 5 is 15. So it's the square root of 15 over 5. You cannot say that's the square root of 3. If you had the square root of 15 over 5, that's 3, you can say square root of 3. If you have the square root of 15 divided by just 5, let me write that down, just 5. You cannot say, oh, 5 goes into 15 3 times. And I'm not going to debate that 5 goes into 15 3 times. I won't even debate that's 5, because that's 5. But you better believe I'm going to debate that that's 15. That's not 15. 5 only goes into silly errors. 5 times 3 is not the square root of 15. So you cannot do that. What if you had 2 divided by the square root of 8? Now, there are 2 ways to proceed with this problem, so we will do it 2 times. Some of you may say, oh, this is simple. I want to get rid of the back radical in the bottom, so I multiply the top and bottom by square root of 8. And the bottom will be 8, and the top will be 2 square root of 8, and 2 goes into 8 4 times. The problem is we can break down the square root of 8. There's a number on our list that goes into 8. This is the square root of 4 times the square root of 2 over 4. That's the square root of 4, that's the square root of 2, and that's 4. And 2 goes into 4 2 times, so the final answer is square root of 2 over 2. My advice would be to break down the radical from the beginning. 4 goes into 8, and I know the square root of 4. So it's the square root of 4 times the square root of 2. Now, this is 2 and that's 2. If you want to write it down that way, fine. They're still 2's. So you have 1 over square root of 2. And now I multiply top and bottom by square root of 2. Square root of 2 times square root of 2 is 2. And 1 times square root of 2 is square root of 2. Got the same answer. In my opinion, it was cleaner to do it that way. Especially if this number is large. 8 wasn't so large. You break things down first and you get smaller numbers. For example, if you had 1 over the 4th root of 8. Now, remember, if you have the square root of 11, and you multiply it by itself 2 times, you get back 11. If you have the 4th root times 11, that's asking for the special number, this is the special number that when you multiply it by itself 4 times, gives you back 11. That is, if I multiply this square root of 4th root of 11 by itself, not 2 times, not 3 times, but 4 times, I get 11 back. That's what the 4th root of 11 means. It's that special number that when you multiply it by itself 4 times, gives you back 11. Now, I won't even do it the long way. The long way would be the following. Take this number and then multiply it by itself. Multiply it by 1. And the way you should write 1 would be the 4th root of 8 in the bottom times the 4th root of 8 in the bottom times the 4th root of 8 in the bottom. And then you have to do it on top. And we'll see how far I'm willing to get this problem using this method. Now, the 4th root of 8 times the 4th root of 8 times the 4th root of 8 times the 4th root of 8. Multiply the 4th root of 8 by itself 4 times. Gives me 8. And the 4th root of 8 times the 4th root of 8 times the 4th root of 8 is the 4th root of 8 times 8 times 8. 8 times 8 is 64 times 8 is, 8 times 60 is 480, and 8 times 4 is 32, so it's 512. 512. And 1 times that is just that. So it's the fourth root of 512. What's the largest number on the fourth root table that goes into 112, 512? 512 is a big number. 2 to the fourth is 16. 3 to the fourth is 81. 4 to the fourth is, I think, 256. 5 to the fourth is 625. And for a lot of you, that would have been very, very, very hard. But fortunately, we hit on it. If you double that number, you get 512. That is the fourth root of 256 times the fourth root of 2 over 8. The fourth root of 256 is 4. So you have 4, fourth root of 2 over 8, and 4 goes into 8 2 times. So you get the fourth root of 2 over 2. But that was hard. No argument from you there. That was hard. The easier way of doing this is to realize that 8 is 2 times 2 times 2. This is, we were given 1 over the fourth root of 8. You should recognize 8 as 2 times 2 times 2. So it's the fourth root of 2 times the fourth root of 2 times the fourth root of 2. But I want to change the way this looks. I don't want any radicals in the bottom. So I multiply by 1. Of course I'm going to multiply by the fourth root of 2. Because then, in the bottom, because then I have it 4 times, and I'll just get 2 in the bottom. I'll just get 2 in the bottom. The fourth root of any number times itself 4 times is that number. And I do the same to the top. This fraction here is 1. And 1 times the fourth root of 2, what do you know? The fourth root of 2. And this is the same thing I got doing it the long way. And I never dealt with numbers like 512. The fourth root of 2 times the fourth root of 2, 4 times gives me 2. Since I had it 3 times, I just needed it 1 more time. If I only had it 2 times, I would need it 2 more times. So you definitely want to simplify first. Sometimes you couldn't simplify. If I gave you the fourth root of 10, 10 isn't like 3 times 3 or a few times or 4 times 4. 10 is just 2 times 5. That wouldn't have been very helpful. Okay, now, last type of problems. Let's motivate it though. Remember, if you have the square root of a number and you multiply it by itself, that is, you take that number and you square it. You just get back what's underneath the radical sign. If you have the square root of a number and you square it, you get back that number. Square root of 13 times the square root of 13 is 13. Now, if you have a minus b, you multiply it by its conjugate, a plus b. Or if you have a plus b and you multiply it by its conjugate, a minus b, you'll get a squared minus b squared. And if a had a radical, if a were, say, the square root of 3, but it does say the square a, and b was the square root of 11, and it does say the square b, well then you will have no more radicals. You'll have 3 minus 11, which happens to be, say, negative 8. If you square a radical, there's no more radical sign. And if you multiply by radicals, you end up with the difference of squares. Okay, so instructions are to rationalize the denominator. That is no radicals in the denominator. So, I have what I have, and clearly I want to change the way it looks because there's a radical in the bottom. That means I want to multiply by 1. We multiply the bottom by the conjugate, square root of 3 plus 2. Just change the sign in the middle. And I have to do the same to the top. 1 times the top is just square root of 3 plus 2. Now, if I consider square root of 3 as A and 2 as B, this here is A minus B. But that's also A. Square root of 3 is A. And 2 is B. That's A plus B. A minus B times A plus B is A squared minus B squared. But if this is A, then that's A squared. Minus, if that's B, well then that's B squared. So we have the square root of 3 plus 2 divided by negative 1. If I multiply the top by negative 1, I'll get that. And if I multiply the bottom by negative 1, I'll get 1. And the rule for dividing by 1 is don't do it. That is, there's your answer. Negative the square root of 3 plus 2. You have 9 over the square root of 6 minus the square root of 3. Well, I want to change the way it looks, which is code for I want to multiply it by 1. The way I'm going to write 1 is, the bottom at least, will be the square root of 6 plus the square root of 3. The conjugate. That's a minus, I put a plus. I have to do the same to the top. Okay, so the numerator is going to be 9 times the square root of 6 plus the square root of 3. And in the bottom, this is A minus B, and over here is A plus B. So I square A, which is 6, minus, and I square B, which is 3. So I get 9 times the square root of 6 plus the square root of 3 divided by 3. 6 minus 3 is 3. And coincidentally, 3 goes into 9 3 times. So you can say your final answer is that. Or you can say, well, I can factor out something from that. I can factor out something from that. I can factor out the square root of 3. I can factor out the square root of 3. And let's do that right now. We'll do it on top. So we have 3 times the square root of 6 plus the square root of 3. The square root of 6 is really 3 times 2. Well, square root of 3 times square root of 2. So when I factor out the square root of 3, what's left is square root of 2 plus 1. And there's a nicer way to write an answer. 3 square root of 3 times the square root of 2 plus 1. It's between you and your teacher whether or not you can leave your final answer like that. Those questions I don't know the answers to. I will say if you did stop at the bottom, then you didn't make any mistakes. But you may not be done yet. If you stopped right there, you didn't make any mistakes. All your equal signs are valid, but you may not be done. If your teacher asks you, what's 2 plus 3 plus 4 plus 5, and you say, well, that's 5 plus 4 plus 5, I know I would not try to put a check mark there. What you wrote is correct. That doesn't mean you're done. That doesn't mean you get full credit. You didn't finish. You have to say 5 plus 4 is 9 plus 5. I put a check mark there. But you're not done. You wouldn't get full credit until you say MS equals 14. But just because what you wrote is correct doesn't mean you get full credit. Because if that was the case, I would have gotten 100 on every one of my math exams ever. I would write down for problem 1, 1 plus 1 is 2. I would do the same for problem 2, and the same for problem 3, and the same for problem 4. And since I'm always getting check marks, that means I get 100% nonsense. Okay? It's not enough just to write down things that are correct. You have to write down the correct things. You have to finish. I had a student once, with one exception, their exam paper looked just like that, blank, which says to me that would be 0%. The only thing they wrote on the test was something like 7 minus 2 is 6, which is wrong. So I felt I couldn't give them a 0, I gave them a -5. And the student was very upset that I gave them a negative grade. Student wasn't upset that they didn't study, they were upset that I gave them a negative grade. Okay. Now, let us do one more problem. And we'll do this problem 2 different ways, one being quite clever. Suppose you have this problem right here, square root of x is -2. The instructions are the same. Rationalize the denominator. Rationalize the denominator. Sometimes they'll ask you to rationalize the numerator. That means you can have a radical in the bottom, not in the numerator. Okay, but unless otherwise stated, final answers cannot have radicals in the bottom. Now, the top, I mean, you can actually factor the top. It becomes this, it's the difference of squares. But since I want to change the way it looks, I'm going to change the way the bottom looks. That's code for we need to multiply by 1. Even if you don't see how you want to multiply by 1, you have to get mathematically mature enough to say, if I want to change the way that bottom looks, I need to multiply by 1. And the answer is to multiply by the conjugates, because that gets rid of square root signs. So top will be x minus 2 times x plus 2 times the square root of x plus 2. And the bottom, since the conjugates, a minus b times a plus b, you get a squared, which is x, minus b squared, which is 4. X minus 4. Okay, I see a little typo. I meant for the top to be just x minus 4. Okay? I just meant for the top to be x minus 4. So it turns out the top did not factor. It's just x minus 4. Sorry about that. The top is just x minus 4 times the square root of x plus 2. That's just what I'm going to put in the next line. X minus 4. X minus 4. And as long as x is not 4 root of x plus 2. So, if somebody asks you, what does this equal when x is 9? I mean, you can do 9 minus 4 over the square root of 9 minus 2, which is 5 over 1, which is 5. Or you can come here. The square root of 9 is 3, plus 2 is 5. They're equal. Now that's one way of doing this problem. It's not a bad way. But I'll show you another nice way of doing it. I think it'll be a little bit quicker, but you're going to have to be a little bit clever to do it this way. Okay, x minus 4 over the square root of x minus 2. I claim the numerator is the difference of squares. What do you square to get x? Square root of x. Square root of x times square root of x is x. What do you square to get 4? 2. The bottom's not changing. It's square root of x minus 2. But the top I'm going to factor. It's a difference of squares. What's being squared? This and that. The square root of x is being squared, and 2 is being squared. The rule has always been, write down the things that are being squared 2 times. In one bracket put a minus, in the other bracket put a plus, and then you say, oh, that cancels. So you get the square root of x plus 2. Exactly what we got before. It was a little bit quicker. Okay, so that's another way of doing this problem up here. That completes the section on dividing square roots.